Alright, so we're going to solve a radical equation, and I'm sure your question is, where's the radical? Well, sometimes they appear in the form of fractional exponents, and an exponent of 1/2 is just another way of saying a square root. So this is the equation x is equal to 5 plus, sorry, the pen didn't, for whatever reason, decided not to write, x is equal to 5 plus the square root of 3x minus 11. Alright, so first thing we want to do is to isolate the square root, and that will give us x minus 5 is equal to the square root of 3, the square root of 3x minus 11. Alright, so now we want to get rid of this square root. So the inverse operation of a square root would be to square. So let's square this side of the equation. So whatever we do to one side, we must do to the other. So that will give us this equation: x squared minus 10x minus plus 25 is equal to 3x minus 11. X minus 5 times x minus 5 is equal to x squared minus 5x minus 5x plus 25. So that's where that came from. And any number in a radical times itself in a square root radical, where the index is 2, multiplied by itself, will equal the same value of the radicand. That's the definition. So let's isolate, this is a quadratic equation, so let's set it equal to 0 by subtracting 3x from both sides and subtracting, adding 11 to both sides. And that'll give us x squared minus 13x plus 36 equals 0. And by factoring, we'll determine the values of x. Now either x is equal to, what are the factors? I guess 9 and 4, two negatives, so x is 9, x 4. So x is equal to 9 or x is equal to 4 are potential solutions to this problem. They're not necessarily solutions, and we have to look at the possible issues here. And that comes up here. The square root of a negative number is an imaginary number, which we're going to talk about in a little bit, but you can't take the square root of a negative number. So if one of these, when substituted into x, would result in a negative value in this square roots, this would not be an acceptable answer. But let's see what happens. 3 times 9 is equal to 27. Minus 11 would be equal to 16. The square root of 16 is 4. 5 plus 4 is 9. And since this side was 9, this would work. Alright, so just to run that down again, I'll actually do the substitutions. 9 is equal to 5 plus the square root of 3 times 9 minus 11. So 9 equals 5 plus square root of 27 minus 11. 9 is equal to 5 plus the square root of 16. 9 is equal to 5 plus 4. 9 equals 9. So that one works. No issues. Let's try that again. Oh, and I'm technically doing this incorrectly. I should really be doing substitution back here, but I would just put it back in the square root in order to do the check, so I'm just going to do it from here. So if x were equal to 4, we get 5 plus the square root of 3 times 4 minus 11. Let's see, that's 4 is equal to 5 plus radical 12 minus 11, which is radical 1. 4 is equal to 5 plus 1. So that's obviously not true. So it actually looks like we have to reject this answer. So this is not an acceptable answer. And that will happen when you change a radical expression into a quadratic or a linear. Sometimes we create a unacceptable solution. But we did find a solution. Alright, so that's pretty much it for this. Thank you.